Hey, this is Neil Patel again. I'm recording this video for the assignment 2 for CS 4242 Artificial Intelligence. Assignment 2 was basically implementing A-star algorithm for I chose 8 puzzle problem and pathfinding for real world application. I'm gonna go ahead and give you an explanation of how my A-star algorithm works. Okay, to start with, the way the A-star algorithm that I wrote works is it starts with a constructor that creates a board that has been passed in as an argument, and then that board is copied, and while it's also doing it, also go ahead and find blank space, which is represented by 0 in my matrix, a 3 by 3 matrix. Then I have a method for calculating Hamming heuristic measure, Manhattan heuristic measure. This find destination row and find destination column basically helps in finding Manhattan heuristic number. Then I have a string method that would print out the string for us, and then a heuristic measure that would used to be the sum of Manhattan and what's the other one, Hamming heuristic measure. But because I was having too many issues with that number, I ended up making it just a Manhattan number. This goal state basically returns what the goal state is, that when the Manhattan board reaches 0. And then the way my A-star algorithm works is it takes the initial board in, and then it checks for the move, check for up, down, left, right, and then whenever it's checking for it, it's storing a heuristic measures for each move in an array, and then it will whenever it's storing it in the array, and then that array is passed on. So this is the method that checks the moves. Basically, it calls another method that's called move test. The move test method basically copies the current state that the board is in, and so that it doesn't messes up the original board, and then it performs the move as defined by the upper mentioned method. That is, if it's a up mode, then it will do up mode. If it's a left, right, and then it will return a heuristic measure for each move. Then these heuristic measures are saved in an array, 2 by 2 array, and in that 2 by 2 array, the first block is 0, 1, 2, 3, which basically represents move as in up, down, left, right. And the second block is heuristic measures. So these heuristic measures are then used to find the minimum. What's the best possible move that we can do for the heuristic measure, for the specific state of the board. And then it will pass that best move to perform move function. That perform move function perform move function is the function that will perform move to the original. That's the board that the main board that we are focusing on, and that it basically uses a switch case statement to see if it's up, down, left, right move. So this functions, up, move functions, they basically call for another function that's basically at first checking if the move is legal. That is, if we cannot move a left move, we don't want to go out of bounds of the array. So it checks that, and then it calls another function that is the function that does the movement for us, and then it updates the positions, backpost positions. So that's how it works. And then at the very end, there is a solve method, which basically has a while loop that says that if it's not a goal state, keep repeating that until it's a goal state. This algorithm that I have designed works for the most part, but it does get stuck whenever there is a loop move. That is that if a function calls for a right move and then it goes through again, and if it finds that left move is most cost value best move, then it will do the left move, and then it will be stuck in an infinite loop. I couldn't figure out how to fix that, and I actually ran out of the time. Another thing that I couldn't figure out how to do was a tree or a node, because I couldn't figure out how to handle heuristic measures and at the same time maintain the state and the depth level of the tree or priority queue, or whichever I was trying to use for implementation. I did try to use priority queue, but it didn't work out. The second one that I did was a real life example, which is pathfinding. My pathfinding function works exactly same as the board one, but it's more efficient and it's more reliable than the board 8 puzzle problem. So the way my pathfinding function works is by it starts by a constructor. The constructor calls for set point and set current points method. So set point method basically sets a random starting point and a random ending point. And then the set current point methods basically sets the start of the array as an start of the finding path puzzle as the current step. And then there's a random matrix that basically sets up the whole array. Then we have print function, which will basically print the current state. Heuristic function. This heuristic function will return the distance between x and y. So it will return how far the function is from, how far the current position is from the end goal. I chose not to go diagonal moves for the purpose of simplicity. This is a similar function, but it just has arguments that I can pass in, so that I can use the current instead of the start one. So this one will be used at start, but this one will be used while the movements are happening. The index function that basically checks whether the move is legal or not, and the boolean function that is checks whether the current position that we are on is the goal position or not. Then I have a check next step. So that check next step is basically, it takes the current position and then checks if the right move is, checks what the heuristic measure for right move is, check what's the heuristic measure for left move is, check same thing for up and down, and then it stores those numbers in a 2x2 matrix. That matrix in 2x2, first column is 0, 1, 2, 3, which basically means up, down, left, right moves, and then the second column is the heuristic measures, representing each in a sense each what's the cost of each move. Then it will go ahead and find the minimum cost. So what's the best what's the best step that I can do to get closer to the goal. Then it will tell that to the perform move function, which is the function that will tell, okay, now we can move the current position to left or right, or whichever is the best move at the moment. At the very end, again, I have find path function, which is a while loop that keeps running until it finds the final path.